an interdisciplinary approach to transboundary water disputes. Jose Munoz and Fransicso Suarez, and Fransicso is giving the presentation.
Well, it's kind of funny because we got the invitation to come here, and we were very thankful, Howard, John, Jeff, and we thought that we were going to talk about things related to water disputes between different countries. And the first thing that happened is that we had a dispute, Jose and I, of who was going to give the talk, you know? And at some point we had to make a decision, just who is going to talk, or I mean, can we share it or not? And we decided to flip a coin, and I'm here, I won, and we are friends, so nobody got angry. Huh? And that could be something that gets more complicated if you are working with different states, different countries, because you have different views. So today, probably the most interesting things about this are confidential, so I can't show too many things, but I will do my best to show as much as I can. Good, so to start with, it's important to see that, well, we are working with different basins. We have water. Water flows upstream, downstream. We can have different stakeholders or water users in different parts of the basins. And the decisions that some of the actors in the basin can have some other impacts in the basin. And that happens within like one basin. And if that basin is inside of one province or one state, it may be easy to try to solve issues if they appear. But when you have international borders, things can be more complicated. When you have a country that shares a river, the countries are linked because they have to use the water, and hopefully they can get an agreement about this. They also are linked because the value they can create from water, and also in terms of the impacts that they cause through development and pollution. This schematic, it's actually from the Transboundary Water Assessment Program. This program have tried to understand how many basins are transnational, transboundary, and in terms of surface water and in terms of groundwater. You may think that this could be a small problem, that maybe we don't have too many basins that are international, but actually there are many, and there are a lot of people that live inside of these basins, and there are many countries too. I mean, we have more than 150 countries that share different river basins. So it's a big problem. And not only that, if you think about groundwater, things get more complicated because groundwater, it's hard to see, you know, and we can see it through science. We can use geophysical tools, we can drill, you know, and we can try to understand some of the processes that are occurring there with a lot of uncertainties. So we know that the boundaries of this type of aquifers are poorly understood, and we don't know them. Maybe we think that we know them, but actually don't. And typically what happens is that when you gather more data, you realize that you need more information to know what's happening. So one of the important things that this Transboundary Water Assessment Program has shown is that we need an effort to try to identify and delineate these aquifers and get a standard to do it. In terms of how many aquifers are around the world, also we have almost 200, and these are the biggest aquifers. So again, it's still an issue that it's important for all the society. This is a slide that shows a general picture of what this Transboundary Water Assessment Program has done. And I wanted to include it here because it shows different things. For example, each one of these squares show socioeconomical risks, some governance risk, and also some biophysical risk. And they are related to aquifers, to lakes, to river, and different water bodies. When you to see this, all these squares, and you will see that in the first column, many of these regions have a red dot. So I'm just going to zoom in into Western and Middle Africa, just as an example, and you will see that that red column has a high risk related to aquifers, and that's related to governance. We don't have international legal instruments that can help us to decide what we are going to do, and that happens almost everywhere in the world. In this example too, you will see that in lakes and reservoirs, you may also have a risk in Africa. There's not too many risks related to the legal aspects in terms of river, but because you in those arid zones you have more aquifers. So for sure, this it's showing that one of the scientific challenges that we have and that we have to solve is understand these transboundary aquifers. So in terms of being more general in transboundary waters, another problem that can happen is that political aspects can overwhelm any hydrologic or hydrogeologic thing that is happening there. And that's important because also we know that the natural system, as we have, for example, more population inside of a basin, what's going to be happening is that more water is going to be used, and roughly we're going to have the same water available for use. And that can create a dispute or a conflict, and if the conflict exists, then probably it's going to be expensive and it's going to be disruptive. It's not something that you want to be in. Luckily, if you look back in the last decades, when conflict appears, water has been able to create a dialogue, and many of these conflicts have been solved, and agreements have been showing up, and people try to do their best. So that's a good thing. So when you do a review of transboundary waters, we have found that we need more scientific data. We need more education and training. And also, we need to define the role of the government to manage all these international waters. Those are things that we think that must be addressed during the next decades. Now, when you think that, what are the tools that we have to work, that we have been using in the past decades, and that we'll be using in the next decade, which is basically one of the questions that we have for the symposium. I went down to the cartography of Chile, and what you're looking at the screen is a map of a location in Chile that was done 40 years ago. And this type of map was the map that we were using to, for example, delineate water basins, were the maps that we were using for delineated international boundaries. And at that time, I mean, you couldn't be very precise. And as time passes, now we are able to see things like this, tools that, like digital elevation models that can give us a much better precision. And moreover, I mean, you can see, for example, international boundaries that were defined previously. And when you just get the new tools, you realize that they were defined not correctly. So these type of tools are tools that must be used in the future to improve our scientific understanding. Another thing that is important is that we need to manage water, and that's a key problem. And we can do that using numerical models. These models typically have been shown to provide good results, and not only in transboundary basins. So I will show some examples, some case of studies of integrated water resource management that we have been working in Chile. So for that thing, I just wanted to put the definition of this integrated water resource management, which is basically a process or a coordinated development to try to maximize the welfare in an equitable manner without compromising the sustainability. And here, the main point is that to solve water issues, we need to have multiple actors, because we always have stakeholders that have different views or use the water for different for different things. The first example that I want to point out, it's a work that we did a couple of years from now in the Copiapó River Basin, which is a basin that it's in the most arid desert in the world, in the Atacama Desert. It's in the north of Chile. In this basin, we used water for human consumption, and we have two main users, which are agriculture and mining, and they are competing for water. Water is scarce, and water they have a competing interest, and the users that are in the upstream part of the basin are using most of the water, and then at the downstream, there's few water for the rest of the basin. So a couple of years ago, we performed a study that tried to investigate how we can manage the water in that basin in an integrated way, and not only to try to solve the issues related to water, but also the issues related to the energy requirements to produce water. So in part, we look at the water energy nexus. And of course, because water has multiple dimensions, we needed to use an interdisciplinary approach to solve the water scarcity problems, to reduce the energy requirements. And we realized that we could use an integrated water resource modeling tool to look at different scenarios. So to build that tool, we needed to go and see what was out there. Hydrometeorological data, geological data, what about the water rights, water users, legal aspects, different location or spatial distribution of intakes, type of crop, water user, et cetera, et cetera. And that work was also conducted with the help of the government, and we were able to create a conceptual model of that river basin. That conceptual model included surface waters, groundwater, all the users. It took data from wells, data from the stream flows, water sources, demand, etc., and also used a decision support system to help to do this management of water. So it was a big model, which was complex to develop in our country because it's not easy to just get all the funds to do it, all the people involved get together and talk about it, but we were able to do it. And main point of this is that after we got this model, we were able to study different scenarios, allocating water, reducing water demands, or different things that can tell people how you can get all together and try to find the welfare for everybody. The second case, it's something similar. It's the Aconcagua Basin. And here the point that I want to show is that once we get more data, for example, geophysics, geology, etc., we can build more detailed models. And the detailed models can help us to, for example, get hydrogeology sections, and also to go and simulate more water flow in this basin, simulate the interaction, the social interaction between the water users, and finally, you again can go and study different scenarios. So this type of models can be used not only in basins like these ones, but also in basins that have different countries sharing the water body. The third case is the Silala River Basin, which is a small-scale example. This is a basin that is shared between Bolivia and Chile. There is no international management body that can regulate things over there. And the two countries have different perspective on these water curves. For instance, Bolivia said that they are entitled to use all the water. And at the other side, Chile said that that river is an international water course, therefore you have to use it in a reasonable and an equitable way. So it seems that the debate it's over whether this basin is an international water course. Just a really quick physical description of the basin. Here you can see the Silala River. Water comes from the Cajones and Orientales wetlands, comes as springs, and they flow towards Chile. The elevation in the springs is about 4,400 meters above sea level. In the border, it's a little less than that. And there are a couple of water uses over there. If you look at the stream flow at the border, you will see that the stream flow it's fairly constant, and the base flow it's very important, meaning that this is a basin that it's dominated by groundwater. And actually that makes sense. If you look at the scientific reports, you can see that this is the north of Chile, the Silala River basin, it's that one over there, and there is evidence that the groundwater basin could be very, very large. So in this dispute, the state of Chile wanted to get the opinion from the International Court of Justice, and they wanted to see if the court decides that this is an international water course. If they do that, then that means that all the states should use the water in an equitable and a reasonable manner, and then that means that you have to consider many aspects within this. Here comes the fun part, because the stick is getting out. No, so one important thing is that Chile asked the help of Howard to go into this case and to lead the scientific studies and the legal aspect of this case. In the slide, you can see Jimena Fuentes, which is the agent of Chile, and also you can see the expert committee conformed by Howard, by Dennis, and also by Jose Muñez, which is the national expert. And all these studies try to focus on two aspects: geological and geomorphological evolution of the river, and the current functioning, meaning that you see the past and how it's working right now. As I told you before, I can't talk about this because it's confidential, so what I can do is show you a couple of pictures of the national team. The most important thing is that in this type of study, we are grateful that Howard's leading us, because he's been able to put together lawyers, hydrologists, hydrogeologists, geologists, ecologists, et cetera, everybody working together to get more data that can tell us what is happening in that basin. So there you can see a couple of field trips that we are doing, another picture of the expert committee. And to finish, just let me say that we think that if we couple, or if we use the type of tools that I showed you before, integrated water resource management, with information from all these different stakeholders, government, legal aspect, we think that we can manage this type of problems. We also need to understand the physical processes that are occurring, both from the past, how things were formed, and how things are functioning right now. And also, we need to get information of the behaviors of the states in the past, what are the declarations, what the maps of them are saying. In that way, you can address this type of problems. And to finish, from all these points that are here, I think I will just get the last two ones. We think that the grand scientific challenge is how you can manage transboundary aquifers. That's a problem that it's complex to solve. And I think if you are able to do that, then you will be able to inform policymakers to tell them how we should behave. That's everything. Thank you very much.
Oh, yeah. Let's take just time for one question. Anybody? Right there.
Yes, that's, thank you for the question, because that's something that it's really relevant. The question was basically, I mean, in some places you will care about the quantity of water, but maybe you have water quality issues. I put this slide again because this slide shows that in a way. Here you can see some biophysical risk, and that one for sure includes all the water quality issues. I mean, I even just removed a couple of slides from this presentation because it was too long. And in one of the slides, I had a map showing the basins that had issues that were mostly due to water quality. So for sure, you will have to just go to each one of these locations to see the importance of each one of these factors. And that also can be taken into account if you build a model that puts some weight into the more water quality aspects. So for sure, that's something that has to be addressed.